Hey everybody, I'm going to go over the 4.1 through 4.3 quiz review. So if you were in class Monday, Tuesday, we're doing this in class Monday and you're taking a quiz Tuesday. If you are at home on virtual, you are watching this instead of being in class, but we're doing the same thing. And then your quiz Tuesday will be in quizzes. So it'll be very similar to this. So question 1, Bill is building a new shed for all of his junk. He has to decide on the number of windows. His options are 1, 2, or 3. 2 door styles, single or a double door, 2 lighting options, LED or fluorescent. And we're asked to make a tree diagram and then list the sample space. And we're going to just use abbreviations to keep it a little bit simple here. So on my tree, my first branches are going to be based on the number of windows. So I'm going to branch off. So he could build a shed with 1, 2, or 3 windows. Let me just use the numbers here actually. 1 window, 2 windows, or 3 windows. And then from there he has 2 door styles. So if it's a one window house, he could still do either door style. So that's single or double. Same thing, he could have 2 windows, but then he could pick single or double door. And then last, he could do 3 windows in the shed and then a single or double door. So our first possibilities are the number of windows, then the number of doors, or the door style, and now finally, from each of these, I can pick either LED or fluorescent lights. So here's LED or fluorescent. And same thing here. It could be a single window, double door, LED, or fluorescent. So I just keep branching off all these. This gives all the possible ways that Bill can put this shed together. Getting a little messy when it gets this big. To save a little time, I paused recording and I wrote all my sample space out. So from this tree diagram, I can generate my sample space. So let me just do a couple of these outcomes. So the first possible outcome, or the first possible shed, is a 1 window, single door, LED light shed. That's right here. My next one, a 1 window, single door, fluorescent light in the shed. And I keep going across my diagram. So I end up with 12 possible outcomes here for how this shed could be built. Now, same situation. Which events in the above example are mutually exclusive? Mutually exclusive means they cannot occur at the same time. So let's look at my choices. So I'm going to pick one of these. A single door single door and LED. So can they happen at the same time? Yeah, they can. They happen right here, right here, and right here. Those are all single doors with LED lights, so it's not A. 2 windows and a double door. So 2 windows, double door, there it is. They can occur at the same time. And then double door and fluorescent. So can I have double door and fluorescence? Yep, I can. Here we go. Double door fluorescent, double door fluorescence, double door fluorescent. And then finally 1 window or 4 windows. I think that should say 3 windows. But regardless, number of windows, I'm not going to have a shed with 1 or 2 windows at the same time. So this would be my choice. And then last question, I think, dealing with the same probability. Based on this sample space, what's the probability he builds a 1 window, double door shed? So let me switch colors. So 1 window, double door. So 1 window, double door. That's here and here. That's 2 out of the 12 possibilities. So the probability he builds a 1 window, double door sheds, 2 out of 12, and I always have to reduce it. That reduces to 1/6. What's the probability he builds a 2 window shed or a double door shed? So let's switch colors again. So 2 window sheds, those are all these. This is me using my outcomes. All of these are 2 window sheds. And then I want double door, so I'm going to add to that these guys, because they have double doors, and these guys. So those are all my possible outcomes for either having 2 windows or double door. You could use the formula and circle all of these, but you'd have to subtract that overlap. I'm just going to go ahead and total these up. So that's 1, 2, and there's 4, 6, 7, 8. So 8 out of 12 ways that this shed's either going to have 2 windows or double doors. Then again, I'll reduce this. It ends up being 3 out of 4. Or sorry, just kidding. 2 out of 3. I'll reduce those both by 4. All right, let's continue on in the practice quiz here, the quiz review. We have this question. In 2004, 48% of college students were male. What's the probability a random chosen enrolled student was a female, meaning not male? So this is a complement rule. So with that complement rule, it's 1 minus the probability it is a male. So female, I'm going to do 1 minus that 48% or 0.48. That's going to give me the probability I pick a male. So 1 minus 0.48, well, that gives me 0.52. So 0.52 is the probability I pick a male college student in 2004. Next, a probability experiment results in the following probabilities. So 0.2, 0.03, 0.58, and x. And it asks me, what is x? So remember, probabilities in an experiment, some things have to be true. 1, they have to be between 0 and 1. So these obviously are between 0 and 1. And the second major thing is they have to add to 1. So if I'm given 3 of the 4 probabilities in the entire experiment, to figure out what this x is, I need to figure out, well, what is that x, such that if I add all of these probabilities, what is that x value that's going to give me that sum to be 1? So I'm going to simply do 1 minus whatever I get when I add those up. So I'm going to add up 0.2 plus 0.03. I'm actually doing this right now. Plus 0.58. I get 0.81 when I add those up. And then obviously if I do 1 minus 0.81, that resulting probability is going to be 0.19. All right, moving on. We got a bag contains 8 red chips, 7 blue chips, and 5 white chips. Choose 1 chip. Find the following probabilities. So a red chip. So that's red over the total. So there's 8 chips that are red. So that's 8 out of, it looks like 20 total. And then again, just like always, I have to reduce this so I can get 2 over 5 if I reduce 8 over 20. What about the probability of choosing a white or a blue chip? So white, there's 5 of them. Blue, there's 7. I don't have to worry about overlap. They can't be both blue and white. So that's going to be 12 out of 20. And if I reduce that, I'm going to get 3 out of 5. And the last one, the probability of not choosing a white chip. So I had 2 ways I could do it. I could just add up red and blue. Or I could do 1 minus I do pick a white chip. And that's what I'm going to go with. So I'm going to do 1 minus the probability I do pick a white chip. That's 5 out of 20. So 1 minus 5 out of 20. That's going to be 15 out of 20. And again, if I reduce that, I'm going to get 3 over 4 is the probability of not choosing a white chip. All right, going on. The following probabilities when rolling a pair of dice. I'm going to let you do these on your own, but you could just use the sample space from our notes. I think it was 2 weeks ago. We've done quite a few probabilities with rolling dice. I'm trying to get this video under 15 minutes. If we have time, I'll go back to it. Number 8, approximately 8.3% of men have a particular type of color blindness that prevents them from distinguishing between red and green. 4 men are selected at random. What is the probability that all 4 are colorblind? That means I pick 4 people, 4 men. What's the probability the first guy is colorblind, and the second guy, and the third, and the fourth? So every time I say and, I'm going to multiply this probability. So I'm going to do 0.083. And I'm going to multiply it by itself for all 4 men. Now, rather than write that out, it's the same thing as saying 0.083 to the 4th. And let me see what I get. We get 0.00005. And again, the 4th, that's the same thing as saying this guy, the first guy, 0.083, and times the second guy, 0.083, and the third guy times 0.083, and the fourth guy. Number 9, back to chips here. A bag contains chips. Choose 2 chips without replacement. So that's important. Without replacement means they're dependent events. So what's the probability I pick a red and then a white? Well, the probability I pick a red when all the chips are in there is 8 out of 20. And tells me to multiply. Now the probability I pick a white, there's 5 white chips still in the bag, but I already picked out a red chip. So now there's only 19 total chips in the bag. So that's because these are dependent events. So when there's dependent events, you have to consider the probability is going to change. And let's see what I get. 0.105. So now we say the same bag of chips, same colored chips, but what's the probability we pick both of the same color? So I'm taking 2 chips, the same color. That could be a red and a red, or it could be a blue and a blue, or it could be a white and a white. So listen to those words I'm saying. And, every time I see and red, that means multiply. Or, every time I say or, it's telling me to add. So let's see what this looks like. So the first way I can get the same color is red and red. So that's 8 out of 20 times 7 out of 19. So 7 because the first one was red, there's 1 less red, and there's 1 less chip. Now I could do blue and then a blue. So, or a blue then a blue. That's 7 out of 20. Because there's 7 blue chips originally out of 20. And the next one would be 6 left out of 19. Or I could do 2 whites. So that's plus again. There are 5 white chips out of 20. But if the first one's white, and then there's only 4 left for the second one, and only 19 left total. And if I put this in a calculator, you might have to do multi-steps if you don't have an 84 or better. You end up getting, this is a decimal, 0.311. I'm only got about 3 minutes left to record, so I'm going to pause here and upload this video, and I'll make a second video for the remainder of the problems on the review.